Asslam Alaikum. In this video, I will explain that how we can compute the efficient frontier based on the multiple securities. In earlier video, I have computed the efficient frontier based on the two stocks, and the link of that video is shown in the upper right corner of the screen. To compute efficient frontier, I have already computed the return of individual securities. I have selected 5 securities listed at Pakistan Stock Exchange and computed their risk and return, and I have also computed the covariance matrix between all these securities. Earlier, I have also computed the portfolio risk and return and explained that how we can compute the portfolio risk and return based on the multiple securities. And in the description of this video, I have placed the link of all these videos. To start with this, I have placed the return, variance and standard deviation of individual securities and assigned hypothetical weights to all securities. That is 20% investment in each security, and the sum of the weights should be equal to 1. Firstly, I will compute the return for the minimum variance portfolio. Firstly, I will compute the portfolio return, and for the portfolio return, I will use MMULT function equal to MMULT, then transpose bracket start, then I will select the return of individual securities, bracket close, comma, bracket start, and the weights of the securities. This function will multiply the weights with the return and find the sum of all values, and the weighted return for the portfolio is 1.65%. After that, I will compute the variance of the portfolio. To compute the variance of the portfolio, I will write again equal to MMULT bracket start, MMULT bracket start transpose, and then select the weights of individual securities, comma, and the covariance matrix that I have already computed, bracket close, comma, and again select the weights of the securities. I have already explained that how we can compute covariance matrix, and the link of the video is also shown in the upper right corner. You can watch that video and learn that how we have computed this covariance matrix. I will press enter, and the variance is 0.96%, and standard deviation is simply the square root of the variance. So our portfolio will provide 1.65% return, and the standard deviation will be 9.77%. After computing the portfolio risk and return, I will compute the risk and return for the minimum variance portfolio. And to compute the minimum variance portfolio, I will use solver feature, solver, and then I will remove all these things. In solver, I will select set objective, portfolio standard deviation, and I want to minimize this portfolio standard deviation by changing cells by the weights of these securities. And in constraint, I will add that the sum of weights of individual securities should be equal to 1. Select the cell where sum is placed, and then select equal to constraint 1. OK, and uncheck this cell and solve. OK. We should repeat this step to find if there is any other solution that solver has. Again solve. OK, but the risk and return remains the same. Now I will copy these values, select these values, copy, and will paste here at the minimum variance portfolios. After that, I will compute portfolio 6 and portfolio 7. To compute portfolio 6 and 7, I will again repeat this subject and increase the standard deviation of the portfolio. Again, I will go to solver and set objective, maximize return of the portfolio. By changing cell remains the same, that I want to change the weight of the individual securities, and sum of weight should be 1, and add another constraint that the standard deviation should be equal to 8%. Earlier the portfolio standard deviation was 7.75%, but next portfolio our standard deviation will be 8% and it will maximize the return of the portfolio. And press solve to solve this function and OK. The solver has provided that at 8% we can get 1.4% return, and that's the maximum return that we can get at the 8%. Again, I will copy these weights and portfolio risk and return and place here at portfolio 6. Again, I will repeat this subject and reuse the solver feature, and I will only change this constraint and change risk to 12%. OK and solve. So the solver has provided that at 12% risk our portfolio return will be 3.47%. And again I will copy weights of individual securities as well as portfolio risk and return and paste here at portfolio 7. After computing portfolio 6, 7 and minimum variance portfolio, I will create another portfolio that will be the linear combination of portfolio 6 and 7, and I will compute the variance, weights and risk and return for that portfolio. To compute the covariance between portfolio 6 and 7, again I will use mmult function equal to mmult bracket start mmult bracket start transpose bracket start. Then I will select the weights of the portfolio 6 bracket close comma and the covariance matrix bracket close comma and weights of portfolio 7. Bracket close and control shift enter, and the covariance between portfolio 6 and 7 is 0.0078. Again I will allocate hypothetical weight, that is, let's suppose 40%, and compute the return on the portfolio, that is equal to weight of the portfolio 6 into return of the portfolio 6 plus 1 minus weight of the portfolio 6 multiply by return on the portfolio 7, and the return of the portfolio is 2.6%. Now I will compute the variance and standard deviation of the portfolio, and for the variance I will use the portfolio variance formula that we have used in the 2 stocks portfolio, that is equal to weight of first security square multiply by variance of the first security, that is portfolio 6, plus weight of the second security square multiply by variance of the second security plus 2 into weight of first security multiply by weight of the second security multiply by covariance between these securities and enter. So the variance is 1% and the standard deviation is simply square root of the variance, So the standard deviation is 10% and the return will be 2.6%. To compute efficient frontier, I will write here the variance of our mean variant portfolio and the return of our mean variant portfolio. And write here -2 and I will add plus 0.1 to decrease it and copy this cell until I get +2 answer. After that, I will select these cells where I have copied the risk and return of the portfolios, that is the linear combination of portfolio 6 and 7, and go to data, what if analysis, data tables and input cell and select the weight of the portfolio, that is the linear combination of portfolio 6 and 7, and OK. So the return and risk of that the portfolio will be computed by using the different weights, that is changing from -2 to +2. And then I will select these values, insert charts, and then I will select any type of chart, scatter plot, and the efficient frontier will be computed. After creating this efficient frontier, I will add here other securities, select data and add mean variant portfolio, its X values, that is standard deviation, its Y values, that is its return, add portfolio 7, its X value, standard deviation and return, that is portfolio return, add portfolio 6 variance and select its Y value, that is return. Okay. And we can also add these securities like NML, select name, X value its standard deviation and its Y value includes its return. We can add all these values, but for the simplicity I am not adding all these values, and press OK. And our efficient frontier is like this. After that, I will click on all these color cells and right click on the cell, add data labels and change its data label by formatting data labels and select series name and remove its Y values. On this efficient frontier, the mean variant portfolio is at the extreme left side of this efficient frontier, where risk is minimum as well as the return is also less. But if we go upside along with this efficient frontier, there will be high risk and the high return, and these portfolios will be efficient portfolios. Like Nishat Mills Limited individually is not on this efficient frontier. It means Nishat Mills Limited is not an efficient security. All efficient securities or efficient portfolios will be placed on this efficient frontiers. But if a security have less risk and return, then it will be not on this efficient frontier. That's all about this efficient frontier. In the next video, I will show you that how we can compute the beta of these companies and how we can place these values on the capital market line. If you have any questions, you can contact us through WhatsApp, Facebook, or write in the comment section of this video. I will try my best to answer your question. Thank you. Take care. Allah Hafiz.